Here, now I am going to explain a class 10, chapter number 2, polynomials. That is, first is introduction to polynomials. In this polynomials, we can say it's a group of terms. Okay, the group of terms. So in the group of terms means, so 2x, if you are considering the 2x, so here it's one is a numerical part, it means number part, and the second one is variable part. So that's 2 is considered it as the number part. Okay, so in that number part you can consider it as a coefficient also. So coefficient means 1 to 100 we can write. Now that is a x, it's a variable. All the English alphabets you can consider it as a variable. Okay, so that is what variable. So in the second example, 2x square. So 2 is also a number part. Its a coefficient is 2. And x square, that is a variable 2. 2 is a power. The power is contains any whole numbers. The whole numbers it is 0, 1, 2, 3, 4 and so on. So all that's are whole numbers. We can consider it as a power. So that's why x square is a one of the variable now. Okay. So group of this, it's together we can write it as a polynomial. So polynomial is a chain. It is a chain of terms. So it's a chain of terms. So you can see that example, 5x is a one term, 3y is the another one term, 2 is the last term. So in between that, it is difference with the minus sign and plus sign. So here 2 is the last term. The term we can consider it as a constant term, we can consider it. How we are getting that constant term? See, let us see. So 2 into x to the power of what? 0 we can write. 2 into x to the power of 0. Okay, so x to the power of 0 is a variable. In the earlier classes, you know that exponents, x to the power of 0 is what? 1. Okay, so it means 2 into 1 equals to what? We are getting 2. So that 2 we are writing in the last place. Okay, that is what? 2. So now 5x minus 3y plus 2, it is about one of the polynomial. It means it is a chain of terms or a group of terms. So group of terms. So now in that polynomials we have different types. First one is 2x. The 2x we can consider it as the monomial. So why it is a monomial means mono means single, one term. So the second one is binomial, 5x plus 3. It's a binomial. Bi is a bi means two terms. So two terms is first is 5x and second term is 3 separated by plus. So now it is what? 5x square, 3x and plus 4. There are three terms are there. So it is a what? Trinomial. They are separated by the plus symbol or minus symbol. But here it is what? Plus. This is what? Trinomial. So it is tri. More than three terms are there means it is a what? Polynomials we are writing. So monomial, binomial, trinomial, and lastly it is what? Polynomials. Now degree of a polynomials. Degree means what? Highest power of the variable in a polynomial. Highest power of the variable power. Variable you have to consider it now. In the example 5x square plus 3x plus 4, here x square and x is the variable. So variable is x square and x. Highest power is what here? It is what? 2. Okay, so that is what 2. Therefore the degree is what? 2. Clear? I hope that all of you understood. In this example, 8x square minus 14x square plus 4x cube plus 3. Okay, so this is our one of the term. So highest power is 6, so degree is 6, but this is not there in the standard form. We have to write in the standard form means highest power of the variable you have to write first. That's what polynomial form we have to write. It is what? Highest power. So which is the highest? Minus 14x to the power of 6. So that is the term. Then after that term, which is the greatest number? Okay, so it is what? 4x cube is the term, right? So that plus 4x cube we have to write. Then after 4x cube, which is the term? 8x square. So you have to write in the decreasing order. So plus 8x square. Then plus last one constant term is remaining, that is what? Plus 3. Okay, so when you are writing that this is a standard form, first highest degree to the lowest degree. It means it is that you have to write in the decreasing order. Okay, so then minus 14x square to the power of 6 is there. With minus sign also we have to write. That's the compulsory. Then here plus means plus. Okay, so it's a plus sign. There is no sign here. So what is the sign is remaining? What is that? Plus sign is remaining. So this is our standard form. Okay, so next in the polynomial, so different types of polynomials are there. There are three types of polynomials. That is what linear polynomial. In that linear polynomial means that is a what ax plus b form, that is a x to the power of what 1. There is no power means it is a what 1. So 2x plus 6 is one of the example for the linear polynomial. Okay, so next is power. See the power degree is for 2, then 7x plus 3, so highest degree is 2. So 2 is there. It is a what quadratic polynomial. That is what quadratic polynomial. Next third one is, so x power is 3, that's why it is what cubic polynomial. So these are the three terms. Next, power of variables in a polynomial is always a whole number. Already I said, so polynomials power is always it's a whole number. It should not be in the form of 1.5 or 2.5 or 1.2. So here 1.2 means what can you get it? 2 divided by 3. It should not be. Okay, so we have to write only in the whole number form. Okay, clear now? So now you can see one video. So for the more understanding purpose, I will show you one video. Please understand it.
A polynomial is an algebraic expression of finite length made up of variables and constants by using only the operation of addition, subtraction, and multiplication and non-negative whole number exponents. For example, x square minus 5x plus 3 is a polynomial. The highest power of the variable in a polynomial is called the degree of the polynomial. Let's take a look at the polynomial 6 minus 3y to the power 5 plus y cube minus 2y to the power 6. Here the highest power of the variable is 6. Therefore, the degree of the polynomial is 6. A polynomial is classified according to its degree. A polynomial of degree 1 is called a linear polynomial. A polynomial of degree 2 is called a quadratic polynomial. A polynomial of degree 3 is called a cubic polynomial. A polynomial is written in the standard form by writing the polynomial in decreasing order of its exponents. An example of a standard form of a polynomial is ax square plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. Let p of x be any polynomial of degree 1 and let a be any real number. If p of x is divided by the linear polynomial x minus a, the remainder is p of a. By remainder theorem, on dividing p of x is equal to x square minus 1 by x plus 1, the remainder will be p of minus 1. Since p of minus 1 is equal to 0, the remainder is 0. Suppose p of x is a polynomial of degree n, where n is greater than 1, and a is any real number. Then x minus a is a factor of p of x, if p of a is equal to 0. P of a is equal to 0 if x minus a is a factor of p of x. To use factor theorem for polynomials with degree 2 and 3, split the middle term.
Now next is zeros of a polynomial. In the zeros of a polynomial there are three types. First one is linear polynomial. It's there in the form of ax plus b. A is not equals to 0. So this is the first form. And second is quadratic polynomial. It is there in the form of ax square plus bx plus c. Here also a is not equals to 0. If a equals to 0, it becomes a linear polynomial. Clear? So now next is cubic polynomial. So in the cubic polynomial, it is there in the form of ax cube plus bx square plus cx plus d. It means the power is 3. Okay, but the a is not equals to 0. Here also a is not equals to 0. If a is equals to 0, it becomes a quadratic polynomial. Okay, so in these all three polynomials, we are getting the different zeros. So linear polynomial is getting only 1 0, quadratic polynomial is getting 2 zeros, and cubic polynomial we are getting 3 zeros. So depending upon the power we are getting the zeros. Okay, so linear polynomial has 1 0, quadratic polynomial has 2 zeros, and cubic polynomial has 3 zeros. By seeing the video with the example and diagram, we can easily understand. Please watch the next video.
Have you ever wondered why the zeros of a polynomial are so important? An understanding of the geometrical representations of polynomials and the geometrical meaning of their zeros will answer this question. Let's start with the definition of zero of a polynomial. A zero of a polynomial is that value of x at which the polynomial p of x is equal to 0. If p of x is a polynomial and a is a real number such that p of a is equal to 0, then the following statements are equivalent. A is a zero of p of x. A is a solution of the polynomial equation p of x is equal to 0. And x minus a is a factor of the polynomial p of x. The x-intercept is that value of x where the graph touches or crosses the x-axis. At the x-intercept, y is equal to p of x is equal to 0. A polynomial function of degree n has at most n zeros. Let's look at the graph of a constant function. F of x is equal to 3 is a constant function with degree is equal to 0. What do you think the graph is like? The graph is a straight line that does not intersect the x-axis at any point. Hence, it has 0 x-intercepts. Now, what do you think the graph will be like for a linear polynomial of degree 1? Suppose f of x is equal to x plus 2. Look at the graph. You can see that it intersects the x-axis at only one point, -2, 0. Hence, its x-intercept at that point is -2. In other words, at the point -2, 0, y is equal to f of x is equal to 0. Thus, the number of zeros is 1 for a linear polynomial of degree 1. What is the geometric meaning of 0 for a linear polynomial? The graph of the linear polynomial f of x is equal to ax plus b, where a is not equal to 0, is a straight line. It intersects the x-axis at exactly one point -b by a, 0. Therefore, the linear polynomial has only one zero, which is the x-coordinate of the point where the graph of y is equal to ax plus b intersects the x-axis. What do you think are the zeros of the following quadratic polynomials? P of x is equal to x square plus 2x minus 15. When we solve P of x is equal to x square plus 2x minus 15, we get x plus 5 multiplied by x minus 3. This implies that P of x is equal to 0 when x is equal to minus 5 and x is equal to 3. Let us see the graph of P of x is equal to x square plus 2x minus 15. What are the x-intercepts of the graph? You can see that y is equal to 0 at 2 points, minus 5, 0 and 3, 0. Therefore, the x-intercepts are minus 5, 0 and 3, 0. Let us see another graph of a quadratic polynomial. F of x is equal to x square plus 3x plus 2 is a quadratic polynomial of degree 2. F of x is equal to x plus 1 multiplied by x plus 2. This implies that f of x is equal to 0 when x is equal to minus 1 and x is equal to minus 2. Let us see the graph of the polynomial. It meets the x-axis at 2 points, minus 2, 0 and minus 1, 0. Hence, the x-intercepts are minus 2 and minus 1. Thus, the maximum number of zeros for a quadratic polynomial of degree 2 is 2. Therefore, we can conclude that the x-intercepts in the graph are the zeros of the polynomial. Now, let's look at a cubic polynomial. F of x is equal to y is equal to x cubed minus 4x. This is a polynomial of degree 3. So, what will the graph be like and what are the maximum zeros possible? Let's take a look at the graph. There are 3 x-intercepts. Therefore, the maximum zeros for a cubic polynomial of degree 3 is 3. Can you find all the zeros and turning points of the graph of f of x is equal to x to the power 4 minus x cubed minus 2x square? When we factor the polynomial, we get f of x is equal to x to the power of 4 minus x cubed minus 2x square. This is equal to x square multiplied by x plus 1 multiplied by x minus 2. The zeros of this polynomial are x is equal to minus 1, x is equal to 0, and x is equal to 2. These correspond to the x-intercepts minus 1, 0, 0, 0, and 2, 0. The graph shows that there are 3 turning points. Since the degree is 4, this is the maximum number possible. A polynomial function graph consists of a series of hills and valleys called turning points. The maximum number of turning points is 1 less than the degree of the polynomial. For example, if the degree of the polynomial is 3, the graph would have a maximum of 2 turning points. In a polynomial function, 0 is an x value for which y is equal to 0. It is the value at which the graph touches or cuts the x-axis. In a polynomial, the maximum number of zeros is equal to its degree. The quadratic polynomial f of x is equal to ax square plus bx plus c can have three cases for the graphs. Case 1. There are two zeros where the graph cuts x-axis at two distinct points. Case 2. There is 1 0 where the graph cuts x-axis at exactly 1 point. Case 3. There are no zeros when the graph does not cut x-axis at all.
By seeing that previous video, all of you understood how to find the zeros. So for the more understanding, you can see this example. The first figure diagram says how many zeros. So that only one curve is passes through the x-axis. So that one point is called as what? Only that 1 0. Okay. So in the second diagram, there are curve. There is a curve. In that curve, there are 2 points are there on the x-axis. Is passing through the 2 points. So one is in the negative x-axis and another one is in the positive x-axis. So that we can consider it as only 2 zeros for the second one. So now the third figure, we have how many zeros? We have 3 zeros. It means 3 different points that curve is passing. Now next fourth one is that straight line only 1 0. That is on that positive of the x-axis. So now next fifth one, it has only 1 0. Why was only one curve, that only one point is passing through there. Now next is the last one, it is the sixth one. How many zeros are coming? You can see 1 2 3 4 zeros we are getting. So all that curve is passes through only that x-axis. You have to consider it. There are 4 different points that curve is passing. Okay, so I hope that all of you understood. Now I will explaining exercise number 2.1. In this exercise, the graph of y equals to p of x, there are 6 questions are there. In that, how many zeros we are getting, we can identify it. So first one is that line is parallel to the x-axis. That line does not passes through the x-axis. So there is no zeros. It means no zero. Okay, so in the second diagram, so yes, it is only one line is passes through the x-axis. That's why how many zeros we are getting? 1 zeros we are getting. In the third example, or third figure, you can see the 3 points are passes through the x-axis. So we are getting at 3 zeros. Now fourth diagram, you can see that is a 2 zeros we are getting. And fifth diagram, how many zeros we are getting? The 4 points are passes through the x-axis. So we are getting how many zeros? 4 different zeros. But in the sixth one, we can consider only 3 zeros. One is the point curve is passes from the third quadrant and it passes through the second and touch with the x-axis only. It not comes under the down or above. Okay, so that is what, how many zeros we are getting? Only that 1 point and the 2 curves type. So how many zeros we are getting? Only the 3 zeros. I hope that this is understood for you. So this type of things they are asking only in the 1 marks side. Okay children, so now next video I will explain to you exercise number 2.2 and relation between the zeros and the coefficients. Thank you.